All right, we are in the remote studio with Matthias Wagner, CEO, co-founder of Flux AI. Welcome.
Thank you. Great to be on the show.
So it says here on the website, you are building the AI hardware engineer. What's your journey to building the AI hardware engineer? That's an unusual concept.
That's a great question. So, I mean, look, I've always been a builder from childhood on, Legos, wooden blocks, whatever. I went to school for hardware software engineering back in Germany, worked at Siemens for many years afterwards, started like 2 hardware software companies out of that, and then 15 years ago moved to Silicon Valley. I was at Meta for a while, both on hardware software as a product manager. And I left Meta in early 2019. And, I've also been going to Burning Man for a long time. And I decided, look, I'm going to take the summer off. I'm going to work on Burning Man projects, right, the whole summer long. And that's kind of how I got back into hardware after like lots of years being mostly in software. And I had this realization that the tooling to make hardware had not improved in my lifetime. And that was so odd because the tooling to make software is like unrecognizable if you compare it to like mid-90s or something like that, right?
Yeah.
It's like bonkers what we can do now. And I was like, isn't that odd, right? Because the supply chain for hardware has changed as such that I can, as an individual now, get pretty much anything manufactured, right? Why has the tooling not caught up with that capability, right? And I think like 3D printing was like an early trend here in this direction to like, oh, you don't need injection molding. You can just 3D print this at home with like $1,000 3D printer. But that thing has been like slowly and gradually taking off. But in electronics specifically, nothing really has happened. And that was kind of weird, right? And so I kept complaining about that to friends all summer long. And eventually a good friend of mine said, Matthias, look, you've been complaining about this all summer. You're either going to do something about it or stop talking about it. And I was like, I could do something about this, right? And so then we started Flux in October 2019. And I think the key insight here was like coming from Meta. Like at Meta, right? We were like far ahead using deep learning and machine learning to power like anything you can imagine, right? And I had seen the power of that technology, right? And it was so obvious that there would be tons of use cases here to automate electronics design, PCB design, with machine learning. And I wasn't even thinking of LLMs at that point. And so we set out to build like a smart design tool, is what we called it back then. I thought about calling it AI, but I didn't want to sound like a lunatic. And so, but then, right, look, you fast forward, LLMs happened in 22, right? And then the whole thing really took off then, right? And it was actually pretty good because, if you're building like an AI code tool, like Devon or Cursor or so, right? You can fork VS Code, right? You can slap an LLM in, and like there's a lot of like infrastructure that you don't have to build, right? If like Cursor or Devon would have to build their own VS Code, that costs $100 million, Call me back in 5 years. And so in our space, right, the opportunity didn't exist to just fork something like that because there was no open source design tool for electronics, like not something good enough, at least not in a browser, not written, with modern architecture. And so we spent the first couple of years building that from scratch into the browser, kind of like a similar journey like Figma did, right? And made that return collaborative and built that with in mind to use machine learning models, right? Built the data structures, right? The feedback loops. We always thought of the tool itself as the reinforcement learning environment, right? And we were just building the interface for users to provide us feedback and correct the agents. And then LLM came along and then boom, right? And that just turbocharged the whole thing. And so, the product today, right? You can perfectly come in, design things manually, or you can have the agent design it for you, or you can collaborate. And I think this is like very similar like in software engineering is most of the time you're doing this collaboration with the agent, right? The agent does research for you or figures out some stuff, right? Or runs some reviews and you can go back and forth until you have your manufacturable design out of there.
Yeah, amazing. I think I got in touch with you because of Lenny, which is who's one of your angels, I think.
Yeah.
And so like, what is the sort of really inflection points for you? I think you've been going sort of pre-LLMs for a while. Did you just plug in GPT-3 and like everything took off, or was there a more complicated engineering story behind that?
Yeah, it's a good question. So I think, I'm going to claim here, I think we were the first engineering tool or design tool that had an AI chat in it. We shipped that, I think, a month or 2 months before GPT-4 became publicly available. And the realization we had is like that there's so much of the job in electronics design is information gathering. Right, you have all these semiconductors, there's data sheets for them, which one are we going to use, right? What are the exact specs? How do I configure that thing? And that like an agent here with RAG, right, would like supercharge the process and you don't have to go to Google anymore. You can just ask the agent, right? And that was like the first product we shipped. And that was, I think that was like February 22, if I'm getting that right, or 23, something like that, right? And And that was like magical, right, at the time. What didn't work so good at the time is we wanted then, of course, the agent to do things for you, to take actions. And if you remember, like tool calling wasn't working that great in the early days. I mean, they even thought of a ChatGPT that tried that early on, and it would consistently pick the wrong tool, right? And that wasn't really working. And I would say like that tool calling, I think, really only became reliable about a year ago, like last October, November, is when the models that shipped were suddenly really good at calling tools. And I think that then changed everything, right? And you see that then all these AI coding agents took off, like massively, because suddenly you could use grep, right? As a tool call effectively, right? That was like a big unlock, because before everybody was just like letting the LLM edit the freaking file, which was like very error prone and slow. And then for us too, right, we were then able to hook in all these tools. Like suddenly you can have like a sub agent that's hidden behind a tool to search the library, right, or figure out pricing and lead times for semiconductors, right. Suddenly you could have tools to essentially gather the context of the current project to like solve the current user request, right. And you could have suddenly tools to add components to your project, remove them, wire them, run reviews, right, and all that kind of stuff. And so that was a big game changer. And I'd say that in the same time, what we saw that there was a big shift in what users expected from an AI tool around January this year, I would say. Where like suddenly, like before users came to us, be like, oh, can you support this manufacturing process? Can you support like lasered vias and stuff like that? And then there was a sudden shift where suddenly everybody asked for, hey, I want to come with a product brief and just get a fully designed board out of this. I don't want to do so much manual stuff here, right? And that just overnight. And I think my hypothesis, what happened, I think in general in the world, is that people changed what they expected from software, from using all these other tools like Perplexity, ChatGPT, and so on, right? Cursor. It's like an overnight shift. We're like, no, if I'm going to adopt a new piece of software to do something for me, it needs to take in a prompt with the problem and come with the solution back to me. I'm not interested in anything else. And so that then led us to really like heavily invest in the agentic capability in Flux, right? And going from like hey, look, I can answer questions and perform single tasks, to like, no, I can take a product brief, break that down into an actual execution plan, execute that plan, adapt as I go, and then come back to the user with the fully designed thing. And then we finally shipped that thing in early October, so like a month ago.
Amazing. Maybe we should show a little bit of the products so that people can get a little bit of a hands-on. For me, when I log in, I see Brainstorm New Project with AI, ESP32 robot controller, Raspberry Pi Pico, and Tesla Vigo display system.
Yeah, you'll see here, when you see on my screen here, like you see all these like test projects I'm running here to debug things. But we have some good examples here too. So maybe to start with, we've built a CAT tool, like an electronic CAT tool that's fully in the browser. It's like real-time collaborative as the Google Doc or Figma is, right? We have like versioning in here, collaborative features, team functionality, all that good stuff, right? All these like basics. And then we have these agents in here, right? And so the information architecture we have is very similar to GitHub, right? Where you can fork things, you can like create branches, right? Collaborate here, merge back in. I'm going to just open here like a sample project. Give this a second to load. And so then we have the full CAT tool here in the browser. So you have your schematic here, for those who are familiar here with electronics. And then you also have the layout editor here, the mechanical editor. And then you can go all the way here to, visualize what the board's going to look like. There you go. All right. So, and you can send this off from here to a manufacturer anywhere in the world, typically China, and they'll, in a week, 10 days, they'll send this back to you fully assembled.
Is that something I can do on your platform, or I have to export a file and send it by normal means?
That's a great question. So yeah, our goal is we want to seamlessly integrate with manufacturers ultimately, but we haven't done this yet. There is these like, there's a couple different standardized file formats that you can give a manufacturer anywhere in the world, and they can manufacture the board for you from that, and you can just export them from Flux. The most popular one is called Gerber. I mean, the other thing we have here, let me just rearrange some windows so I can see it. We have, the full supply chain integrated, so we can look here at what this board is going to cost for this component,
Wow.
What's it going to cost? Is it in stock? What are the lead times, right?
How do you know?
Kind of stuff.
How do you know what the costs are?
So, we've integrated with all the semiconductor distributors.
Okay.
and we can look up what's in stock there, what will be the lead time. So you can see here, Arrow here in this case, right? They have 0 in stock of this component. DigiKey has 234, but the price here at unit count of 1, right? And all this good stuff. And the cool
And
thing
doesn't
is,
it
right?
matter the volume? Because
Yeah, the volume does
usually,
matter. So at volume 1,
I see.
it's $2.64. At 10, it's $1.66, like 48, it's $1.25 and so on. Yeah, you have the price breaks in here. And so that's great, right? Because the agent can query this too, right? And then a component being on stock is absolutely critical if you want to design and build something. If you think about legacy tools here, they don't have these integrations. They also don't have AI for that matter. But it's easier as a result to design something. And when you have a design with, say, 500 components, and one of them is not on stock, or there's a lead time of 200 days, then the whole project has a lead time now of 200 days, right? And so that's a huge problem, and that's something that the agents here also help in the tool, right? So for example, if we ask you, let's go back to schematic. This is IC1. So we can ask you the agent, this is one of the simpler tasks, right? What would be a cheaper replacement for IC? There. Right? And so the agent can go now, look into the marketplace at all the distributors, right? Find suitable alternatives, look at availability and pricing, right? And come back to us. And this is going to take here 30, 60 seconds, hopefully. And it's like, this would have taken us hours to do manually, right?
Yeah. Are you using MCP under the hood by any chance, or regular?
We don't use MCP, no. This is just all regular function calling, but we own the whole pipeline here. So I feel like MCP makes more sense if you want to interface with third-party services, right?
Yeah.
But no, it's all function calling. We use LangChain, LangGraph here under the hood. So of course, it answers with a counter question here. Let's do, we want a drop-in replacement.
And was that a by the way, can you zoom in on this left side? Because
yes,
it's a bit hard to see. It's very small. Was that a decision to do a counter question? Is that part of the process, or the model just came up with it?
That's a great question. No, we go back and forth of that. For like certain kind of requests, we want the model to default to action. So for example, right, if you're giving it an actual plan to execute, we're really trying to just jump into action, just start working. If the user wants changes, they can just ask for that, right? But for other things like this one here, right, what it asks here is whether we want like a drop-in pin-compatible substitute, right? Because that would mean that we don't have to redesign this whole thing, right? And so that's like a critical question, for our search.
Yeah.
But it's definitely something that's like, I would call this like personality design here, or the personality UX of the agent is something we talk a lot about internally and iterate a lot about, right? So then you can see also what it does here, right? So we have our own library for all these parts, over 1 million. That's all user generated. It essentially does a tool call now. It runs a hybrid search against that. And in some cases, it'll even actually kick in an agent, like a plan execute agent here to be like, okay, look, here's this part we're looking for. We're looking for alternatives to this that are pin compatible. Let's brainstorm the different vendors that could be offering this. Let's brainstorm the different search queries, right? And then we'll perform a bunch of searches, look at those, evaluate those, and eventually come back to us here with this recommendation.
That's a very, very wide search space.
Yeah, it is, right? And the other thing it does is sometimes the part might not be in our library. And so then it will do a web search, right? To find a suitable, alternative that is in our library.
Is that, again, do you use any third-party tools, or you made that yourself? Like Exercise? It's very popular here in SF.
It's all our own stuff.
Web search. Wow.
We use for the vector search, we use Quadrant. Semantic search is Algolia, right? And then we just fire them off in parallel and see what they come back with. We fuse the results then and re-rank them. Like I said earlier, all the agent stuff, that's all LangGraph, LangChain. Trying to think of any other notable third-party stuff we use. I mean, OCR, we also don't do ourselves. We use Azure for that. So yeah, here it came back now, Another cool thing is let's look, right? So look for pin-compatible alternatives. And so pin-compatible, you're only going to find other ESP32s, right? But yeah, I offered to swap those, right? And this is the common lowest option. So let's ask you what the actual price for this is here. I was like, going, oh yeah, the knowledge suggestions here, right? So another thing we've built here ourselves is like, a user-driven knowledge base, where like as the
Okay.
agent learns things, and let's see what I learned here, right? It's like, right? What I learned here is like that when we're replacing ESP32, we want a drop-in pin compatible thing, right? And we can now accept that, we can edit that, we can reject that. And what's really great about this is that it enables personalization on a user level, on a project level, or organization level. And I think that's like critical now to AI systems. And like, if you ever use Tesla self-driving, right? It's magical. But you have a construction zone for 2 months in front of your house. It'll just not pick up, right, which lane to jump into and stuff like that, because it doesn't have a real-time personalization layer
It doesn't
built
have
in,
memory.
right? And that's a huge issue for these systems, I think. And so, yeah, we built our own thing here. And what's really cool is, right, it's like you have the ability to like centralize for your team to manage this knowledge, right? And the agent creates these suggestions themselves, and they're really good at picking this up, right? So yeah, that's a game changer. But we also found that we have then system level knowledge here that we train the system to do. And that's really also how we use mostly the off-the-shelf frontier LLMs here, and the way to like get them to behave the way we want them to behave is just with context engineering and injecting the right knowledge for the right kind of task they're doing, and that's incredibly effective, right? That reduces hallucinations, that makes the model answer in a specific way over and over again, not just 1 in 10 times.
Okay, that's amazing. Maybe I could ask for one more sort of from scratch
Yeah, let's do that.
project, just because I'm obviously a bit newer to this, but I've actually tried to do this. I've actually bought ESP32s and failed to do this. So my project is to make my own smart Alexa, right?
Yeah.
It needs a beamforming microphones. It needs like on-device wake word inference, and then it needs to be able to call some API externally, and then it needs a screen.
Yeah.
Is that all within the requirements? I don't know about the screen part because you
Yeah,
handle
no,
PCB, right?
that's actually great. So why don't we use that, right? So I want to build an Alexa type device
So like
with
let's say speaker, microphone, screen, and then some wake word inference. I don't know what else I need. Battery is nice to have. So the
needs
power
to
draw is like a
be
really interesting
battery
requirement.
powered, and the battery should last a week. Probably Wi-Fi enabled, right?
Oh yeah. Yeah, that's enough. We don't need like too many requirements. Obviously, we could add things,
Yeah.
but I just want to see like for the audience, like probably something they've thought about wanting and they don't have. How quickly can I make it a reality, right? I think that's the real problem with a lot of software engineers who want to start with hardware that they don't know what they don't know.
Yeah,
It's
absolutely.
exactly what I ran into. I bought the ESP32 with like some dev kit things, and it's a bit slow, and the firmware that was preloaded was like really bad, and then I was just stuck.
Yeah. It's a little bit of a steep learning curve. I would say that AI makes that a lot simpler today, especially the debugging process, right? As a novice, for example, there's like a thing that's like decoupling capacitors that you have to like set for like something like ESP32, right? Otherwise, it won't work or it won't boot. And this is kind of stuff, that's like nobody points you at until you run into that issue. And the AI agents are actually really great at being like, hey, look, I built this thing. It's not doing the thing. Why is it not doing the thing? Right? And the agent will be great actually at helping the triage, and finding these issues and teach you. It came back here with a plan. So let's look at this, right? I'll design a battery-powered Wi-Fi voice assistant, mic, speaker, and screen targeting 1 week of battery life. I'll define the system, and I got a low acceleration load switches to hit. Yeah. Oh yeah, we didn't define how we're going to charge this thing. USB-C charging. Fantastic, right? Before The wake model, always listening, raise workload, or button to, yeah. So these are good questions, right? What wake model do you want? Always listening or a button?
Yeah, always listening.
Yeah, right? That's what I'm thinking too. And then, yeah, the screen
Yeah,
size here.
OLED. Yeah, OLED.
Like a
Just do
small
OLED.
OLED is great. And then cell types.
I don't know.
Yeah. This is great. And we could ask this now, but I'm just going to go with here the 18. This is
Yeah.
different. This is a typical lithium-ion battery, the 1865.
Yeah.
Let's go. And then,
You know what'd be interesting is like if there was like sort of little help buttons on each term in case you needed to like do a side chat.
yeah, for sure. We have some of that, but you're totally right. It's like this one would have been a great candidate for it,
Yeah, exactly. Because you knew that for your previous context, but I did not know that. I would have to search. But if there was like a little eye icon, I could just click on it and then it would just tell me.
It's really interesting. I was just last week, I was sitting here with Devon thinking through, or maybe we have like a right-click context menu here, right? Now it's going to go do a Google search here in Chrome. I'm sure you can see that on the screen share. But to just ask a follow-up question based on this term, right? So I was just thinking in a similar vein, but I like this use case you have. You have just there could also just be an I button, and that just triggers like a pop-up or so, within AI summary or so what this thing is. I love that.
Well, in Windsurf, we actually have this like thing where you can click on any symbol and it generates a deep wiki for you. A deep wiki is just kind of like a Wikipedia entry on it. Yeah, right?
I just reinstalled Windsurf last week
for
nice. That. Also, like what are they called? The code maps that just
code
shipped?
maps.
Yeah,
that was
super cool.
I worked on that launch.
Awesome. Yeah, I know. That's phenomenal. Now, we use Devon here religiously, and I think one of the most underrated features of Devon is the actual ask feature. Because I use it even for my handwritten PR. So I'm like, no, let's just talk about this a little bit first here,
Yeah.
Because I think that's also a thing here, what I'm going to say is I think a lot of success, it depends how well you flesh out what you want to do, right? Like if you just use this and ask it to like start here executing a plan, it's going to be high variability in what you're going to get back, right? But the more we go through here and specify, the better it's going to be, right? And you see that here, right? There's tons of more questions, right? OLED interface, this or that, right? Speaker size, right? We're going to ignore all this now, just tell it to just get going. We can actually look at the plan, the execution plan it's created here. Let me resize this. Right, so here's the goal of the project, the implementation plan. Got to do a schematic, got to add all the components, got to connect all the components, then invalidate the power architecture, and so on. So we're just going to tell it, let's go.
Let's go. So first of all, before you this call, I actually didn't even know you used Devon, but yes, I also work on Devon. So it's kind of cool to see this.
We love Devon here. Yeah, I mean, and a lot here is inspired by Devon, like the knowledge base thing, right? Is inspired by Devon.
Yeah. There's a very similar idea. So I was wondering, if you had any references there. And something that's interesting is the team has been working on computer use inside of Devon. And so what you have basically is like kind of like a cursor or Devon for PCB and like hardware design, right? And it's a very complex, dense user interface. And so typically, Devon would not be able to like see this and navigate it. But recently they added computer use into Devon where it's got pixel precision on pressing buttons and typing into the text field.
I'm pretty excited. Actually, this morning. I've yet to try it. But you're totally right. So I'd say the previous version did pretty well navigating our interface. Where it struggles are these canvas interactions.
Yeah.
Right? Like specifically, I don't think it is able to do dragging gestures, like mouse dragging gestures, which is an issue for like a canvas-based thing.
Yeah, I mean, I think it's just a tool call. We can add that in. I don't think
I would love that. Tell the team, please.
I know exactly.
Be willing to dog food that.
Yeah. Okay.
But yeah, I haven't tried to use computer for that use case yet. My hope was that maybe dragging is supported now. But yeah, I agree. Right? I think especially for us, also,
I don't think we tried it yet.
Like a task I've done a lot of work on is just export formats. But you need to test the exported file in some third-party software. And I have installed it on the VM for Devon, right? But then Devon can't open that. It can only use the command line version of these tools, which is oftentimes limited, So I'm really excited about Use Computer, even more excited about the Mac version that's in the pipeline. Because, again, our Canvas stuff is all reliant on WebGL. And at least the previous implementation of the browser didn't have a GPU available, which made the app super slow.
Okay. I mean, I'm sure these are things that the team want to hear from you. Yeah, you're talking to exactly the right person.
Yeah.
I can route you
No,
to.
I can keep on and on and on. We'll be another 2 days, with all the things I'd like. But maybe here, back to what we're doing. So you see here, it's chugging along. It's finding now all the components we need for the project. Right now, it's looking for an MCU that's Wi-Fi enabled and has a wake word coprocessor, right? Because the way this works, especially with a battery-powered device, you want to save power, and so you don't want to leave the MCU running the whole time, right? So simply how it's solved is that you have like a subprocessor here that stays on, that's low power consumption, that just listens for the wake word. But yeah, as soon as it finds the components, we're going to see it's going to start placing this, right? So you can watch here as it does the job, and we can talk to it and make corrections or changes, right? And give it feedback. Any questions you have while we're waiting here?
I mean, it's really interesting because, like, obviously, this is much more of a difficult problem, but I wonder what you could do with pre-visualizations such that the center screen doesn't remain blank while you're doing this design phase. Like, how can I use this time while the bot is thinking and creating to provide the next phase of input? I don't know how to do that.
We've been thinking about that too. I mean, a cool thing Replit does, at least for like a first user session when they sign up, is they use the canvas on the right side to like market features of Replit. All the things you can do, right? And that works. And that's like, I think for a first user session, that's great. That doesn't work so well, I think, for like, somebody who's already onboarded. Another thinking we have here, right? As these agents here we deliver become more reliable and capable, maybe by default, we don't even show the canvas and everything on the right. We'll just show you this chat, and off you go. Another thought here is also like, look, right now this agent is as slow as it ever be, right? I think here now with, we'll be seeing the trend going also with the coding agents, fine-tuning open source models and like way faster as a result, way more accurate. You can actually beat frontier models on quality that way. I think a lot here, what's going to happen in the next 6 to 12 months on our side is just like, having specialized. Yeah, so it found an MCU here for us. We can look at this thing here. Yeah, went for an ESP32. That thing is Wi-Fi enabled, has Bluetooth too, right? Has an onboard antenna, makes it really easy here. We don't have to design our own antenna.
Why are all the hashtags in the description?
Oh, this is for search. You can manually search here, and so that way you can like say hashtag Wi-Fi, right? And you'll just find a lot of Wi-Fi related stuff. So it's just something users have adopted here.
Yeah, the renders are very, very pretty.
Thank you. Yeah, a lot of this is also like you need to like see what it looks like.
Yeah.
Right? Like how big is this thing actually?
Yeah, you get a rough idea based on this.
Yeah.
Yeah, and I noticed that you have a bit of a social network, right? Like you have usernames, you have followers, and you have like the usage graphs and all that.
Yeah, everything here is user generated, right? The whole library is user generated. Again, it's like the spirit of GitHub here. Why does everybody have to like maintain their own compression library, encryption library, right? Extract emails from strings library. If we could just have this joint repository that is GitHub for code, to compete on the best implementation of a given thing, but then also distribute that and have this feedback loop, right? And so it's the same thing here, right? This representation of the ESP32, right? There's ergonomics to this. How good is the 3D model? Is the right datasheet linked, right? All this kind of stuff. Does it have the right part number? And so you want this like friendly competition here about building the best representation, the most ergonomic representation, right? And so that's why the user-driven approach here has a huge advantage. Plus, if there's something missing, users can just add it. They're not reliant on us.
What are we looking at here now?
Yeah, I was just going to say, so it found an MCU with a wake word coprocessor, added that. Now it's looking for the audio path components, right? So the speaker, the amplifier, right? You can see it's looking for Class D audio amplifier. Oh, it seems like it's found one.
Yeah, this is a lot of autonomous thinking and searching.
Yeah. And so yeah, here's our speaker. This is our amplifier here, right? That I just added. And what's this? Oh, this is the microphone. It's an onboard microphone.
And typically, do you buy these parts separately and then there's a third party or middleman assembles them for you before shipping it?
Great question. So, I mean, there's literally 10,000s of manufacturers out in the world.
This is like the Shenzhen markets.
Yeah, right. So totally, right. So I think a popular option is in China is GLC PCB. They'll take the design out of Flux and they'll print the actual PCB board, right? And then they assemble it for you. And they send it back to you. Right? And it's a popular option because it's easy, it's cheap, it's fast. Like within a week, 10 days, you have it back. Right? And you can have 20, 50, 100, doesn't matter. But look, some people also, they want to solder it themselves for whatever reason. So they just get the board printed somewhere, order the components themselves from a distributor, and then solder it themselves. Yeah.
Well, I think you're probably coming close to this project being done. I just want to think about the AI engineering here, right?
Mm-hmm.
You said you use LangGraph, LangChain. How do you iterate on your agent, right? Do you have evals? Do you have A/B tests? Or do you vibe check? What's the rough process?
All of that. So, I mean, we got here essentially layer by layer, right? So we built first the cat tool essentially. Then we built like knowledge retrieval agents on top of that, right? And then from there we went into tool calls, into being like more sophisticated knowledge retrieval, and then we started having evals for these kind of things, right? So these like foundational layer kind of stuff. And it's always a little bit of a mix of like evals and just vibe checking. Because in the end, it's not enough for the evals to pass, right? What's the latency here? Is the response too verbose, right? Do I have all my links in here, right? What's the information presentation really that matters, right? And so that kind of stuff we do a lot with just vibe checking, just trying it over and over. But for things that are more deterministic, right? Like, look, we need to find an ESP32 in the library, right? For that, we have evals, right? That we run. And so, but then on top of that, then we started building these agentic features. First was, it could perform single actions for you. It could add a component, remove a component, make a connection, right? And then again, for that, we have evals to harden that. And then once we had that like working, we started building the actual like agent now, this long-running agent that we're looking at on top, right? And for that agent, to be honest, that's mostly vibes right now. There's an increasing amount now of evals that we have, right? But I think how the V1 here was built, or the V0 of that was built, was all vibes. Because you're just moving faster. I think the problem with evals oftentimes is like,
it's very common.
If you're early and you're still changing the architecture a lot, right, the evals can get in the way. It's a little bit like unit tests sometimes, right? Or like regression tests. If you're like still iterating a lot and changing a lot, it's easy for like,
it's too early.
Like, yeah, it's too early, right? But yeah, it's kind of like, it is very similar in that sense to like regular code writing or like deterministic code, right? And that regression tests are nice, but there's all these typical issues with them. That they take a long time, they're flaky. And I think evals are very close to like regression tests are. They take a long time to run, they're flaky, they need a lot of babysitting. One of the major challenges is surprisingly prompt management, call it.
Mm-hmm.
But there's so many like sub agents here and sub agents. They all have their own little prompts. And managing that, and then also like even like we're getting to a stage where we want to reuse blocks of prompts in other prompts. And you can put this all in code, of course, right, as like text files into your Git repo. What we found is like that, for our vertical, we have like domain experts on the team here that are electrical engineers, hardware engineers. And we need a way for them to easily improve these prompts, right? And the turnaround of like committing, like opening a PR, landing that PR, it being deployed is just too long. So most of our prompts live outside of the Git repo.
Where?
In Langsmith, actually. And we've been pestering, them over there to implement like a concept of blocks so that we can have more reusability. right?
What is a block?
Isn't if you think about like a prompt and it's like, I don't know, 15 paragraphs,
I see. So
right?
sections of a block, sections of a
Yeah,
prompt that are reusable. Got it. Got it. Got it. It's interesting how like all these are generally re-implemented everywhere. Like, yeah, there's a lot of like Jinja templating. There's a lot of like just concatenate strings. There's different ways to concatenate strings, basically.
Yeah. We're trying to find like the one way to rule it all. We also have a bunch of hard-coded strings in the code, of course, right? Where like we don't change them a lot. It's fine. It just lives there hard-coded. Would it be nice to also be in LangSmith? Sure, but nobody has the time to migrate it or whatever, right? But the ones that we work on a lot, they're all in LangSmith right now. And there's some great things about that. I mean, we love the sandbox there. We use it for tracing too, right? And it's nice to be able to like open a trace, go from there to the sandbox, make some changes to the prompt, rerun that, right? I think it's phenomenal, right? From a UX point of view for us here. But yeah, I guess the CMS for the prompts itself, we've been poking them there to invest more.
It's basically a CMS, right? Like it's a very interesting form of CMS with like transclusion or like reuse and templating so that you don't mess up the formats and all that. I think it's an interesting problem. I would say that the prompt management startup category has not been that promising. I think there's like prompt layer that has been there. Human Loop got recently shut down. The company got acquired by Anthropic. Myth has that. Brain Trust has that. It's just not super clear to me where in Cognition, in fact, we have an internal one that was built basically the same time as Devon, the original Devon. There's an internal playground that was built that iterates on Devon's prompts. So the pattern that you found with LangSmith, they independently invented 2 years ago for building Devon.
And you have to, right? Because it's all about iteration speed and being quickly able to test new things, right? In LangSmith, we use you can label your prompts, and we use that a lot to like deploy a prompt just for like a single user, right? We like hacked our own system around that, right? But it's very obvious, right, that a better CMS is crucial, I think, right? But I also think the reason why these startups haven't done well so far is I don't think we understand the problem well enough yet to abstract a generalizable solution, right? And I think that's where everybody is stuck, right? Even what LangSmith offers there is like, we use it, we've not found anything better, but it is so early. But I think it will happen. Somebody will figure it out. And I think you need to connect this with the traces so that you can go seamlessly back and forth, right?
Yeah, it's one seamless tool.
Yeah, and you need to connect it also to like split testing, right? So that you can deploy a change just internally, just to yourself, to 50% of the user base, right? These things all go together, I think, ultimately.
So you use LangSmith for all that? Do you have to bring anything else to handle this? Like
we use stuff? For split testing, we use here Launch Darkly. And there's a lot of overhead to configure a split test for a prompt, as you can imagine, as a result. So it's not great. And then, we use tags. Like I said, you can tag prompts in LangSmith, and then we have an internal system on a syntax for these tags to say, but this tag, this is like a user tag. We're only going to deploy this prompt to this specific user, right? Internally, or just to everybody internally for us. Or no, this is public now, right? This is the production tag. And so that's kind of like, better than nothing. It's not great, So yeah, I think it's just goes to show that I think a lot more here to be figured out before somebody I think can successfully build the prompt CMS to rule them all.
Yeah. Okay, just checking back in on this agent. How far is there like a progress bar on the plan?
There's no progress bar. We've been thinking about that.
It's like an interesting problem of like you don't know. It's like a stopping theory, right? Like when we have no idea how to predict when the agent will be done, but we have some idea of like how much of the plan have you completed, right?
Yeah, so I think the way we're thinking about it is we haven't shipped or built anything here yet, but what we're thinking about is like you have here the plan, and we just want to show what tasks you have been completed. We can sort of like manually do this, right? It's still adding components. So we're very clearly here still in the in the schematic development phase, right? Adding here the components, right? Right now it's loading the power related stuff. So yeah, we're at step 4 here, right? Next would be USB. Then we will move over to connecting components. So yeah, the average session is, I think, 25 minutes.
Wow.
Right?
Still, you're doing a lot of work.
Yeah, I mean, I think like, from a complexity point of view, it's no different than writing software.
Yes.
The constraints are just different here. Like in software, essentially, you have like infinite characters available, and you can always just write the function instead of finding a library that does it, right? And here you can't do that. You need to find these components, and they need to be compatible with each other. And they need, each of these ICs needs supporting infrastructure. And you need to poke all this together. That's not to say that there isn't ways to make this faster, and we're working on that, right? But yeah, the first goal is always just to make it work. And then,
yes, make it
then we'll
work,
figure out how
make
to
it
make
fast.
fast.
Right, make it fast. Yes. Yeah, so I think like let's talk about like the sort of business side of things. What are the milestones that you've reached that you can share? And also like what is the grand vision, right? Like I think like one thing that is unclear to me is, is this for hobbyists? Is there a broader like industry use case that you're going for? What is your sort of core audience that you're achieving?
Yeah, great question. So we have 7,000 paying customers today. That's like, it's grown, it's like 26x versus last year. All right. So like
Wow.
massive growth here.
And
It's
all
pretty
word of
crazy.
mouth, like, yeah.
Yeah. So it's all organic, right? People find us on social media.
You have a very good video
Perplexity are big. Yeah.
on your YouTube.
Yeah. The team here does great work on social media content and videos and tutorials and all that. Google search is also a big source of users, right?
Is there like a big Reddit?
There's not a big Reddit. No, I think none of us here are huge Reddit users. So as a result, we're not big on Reddit. But we have a community Slack that's pretty active. We're hanging out there too with users. That's probably the main channel to interact with users today. And then what was I going to say? Yeah, so this, most of users are self-serve. We have some enterprise customers already. Big Fortune 10, 5 companies, right? They're starting to adopt it. We have a lot of we have a lot of individual engineers at large companies. Like, if you look on your desk, the brands you see there, we have like some of these 50, 60, individual engineers using the product and are paying customers. It's very like similar to like Notion or Figma's go-to-market motion here, right? The product leads here 100% focused on improving the product, on enabling users to get more value out of Flux, right? And that's how we think about the go-to-market motion here. In terms of what's the ambition here, I mean, look, right now, we're focused on PCB boards clearly, right? But I think ultimately the vision is like, if you look at how you can prompt a poem into existence with ChatGPT, right? Or a piece of code with Cursor, we want you to be able to prompt hardware into existence. And not just the PCB boards ultimately, but the full thing, right? Like, why would you not be able to prompt a smartphone into existence? Right? And if you can do that...
That's a lot of parts.
That's a lot of parts. Yeah. That would be 1,200 parts or so, right? For a smartphone.
For reference, this is how many, what we're doing here is 10?
This is probably going to be like, when we're done here, probably like 50 or 60 or so.
Wow. Okay.
And so look, and if you can prompt something like a smartphone into existence, then why would you even still go to Amazon and spend 2 hours searching for a product if you can just describe what you want and get it made and sent to you within a week, right? And I think the counterintuitive thing is that we've been all led to believe that to make things cheap, they have to be mass manufactured. And that used to be true in the past, but that's been changing, right, through automation. And many of our customers now, right, the total cost of ownership now of their electronics or whatever they're doing is like 1/100th of what it was before, right? Because if you can have an AI agent produce the design for you, then you're only paying material costs to manufacture it. And that's a fraction of what you pay for an off-the-shelf smartphone, an off-the-shelf Alexa device, you name it, right? Now, of course, there's some categories that are they're going to take a long time to get to. I think like doing something like an iPhone is going to take a long time, simply because the iPhone enclosure is essentially a piece of jewelry. So that's going to take a while. But if you think about it, the majority of electronics like manufactured every day aren't iPhones, not even close, right? Like electronics are in everything you use, your headphones, your car keys, your charger, your microwave, your washing machine, your thermostat, your car, right? I mean, it's just everywhere. And so there's a lot of low-hanging fruit here for us to come in and help these companies that make these products, customize them more, make them cheaper, make them more capable. And so we have a lot of vending machine manufacturers use Flux. Because there's electronics in vending machines, right? We have a traffic light companies. Because guess what? Traffic lights, right? There's a computer in there, right? We have farmers making their own farming and farm automation equipment with Flux, right? So wherever you look, where there's electronics and automation, right, we're coming for that. And I think this is the end for most categories of the OEM model, ultimately.
This thing looks like it might be taking a while, and I do have to jump to the next thing. Is it done? It's done.
The work's done.
All right, maybe we'll review it a little bit, and then we'll.
Let's do it.
So how do you look at it? What do we do? What does the person do next? Yeah.
Yeah, exactly. Good question. So let's look at what it came back. So it says, it's done here, and all the key components. It wired all the key components here. Oh yeah, we quoted some estimates here on battery lifetime. What it's not done. The low power wake up has not been added to this schematic. Okay, we need to go find that. There's some things it can do that we have to do manually here, it told us. And success criteria. So then recommended next steps, right? So yeah, we need to do some research on the wake word coprocessor, and then go to the layout here, figure out the antenna stuff, and then we can use auto layout, for placement and to run the ERC, DRC checks. So that would be the next steps here, right? But we got pretty far here, right? We got all the components here. We can now go in here, review this manually. We can make manual changes. So again, this is very similar to what the workflow looks like with Devon or Cursor, right? The agent will get you to a given state until it either is done or needs feedback, and then you can take it from there.
But no, I think overall super interesting, and I think you are realizing your vision of AI hardware engineer. I guess the last thing is any calls to action on both the try us outside and the hiring side.
Yeah, absolutely. I mean, definitely come, right? If you're a hardware engineer or software engineer interested in hardware engineering, I think we're dramatically lowered the barrier to entry and speed the process up. So definitely come check us out, provide feedback. This is day one. There's a lot more work to be done, and we would love you, be part of this and help us out and direct us. On the hiring side, look, we're hiring. We're hiring software engineers. We're hiring hardware engineers. We also have a bunch of go-to-market roles open we're hiring for. And I think we're looking for people who are, excited about making hardware and democratizing hardware, and excited about AI here, and really inventing what the next generation of hardware design tooling looks like, the next generation of CAD tooling, what that looks like here with us. And so it's exciting times,
Well, a lot of there's even interesting technical questions around the canvas that you're doing. It's such an interesting, challenging problem.
Yeah, it's a whole can of worms on its own. The whole WebGL rendering that can be performant in any browser, on mobile browsers, memory usage. I mean, there's no shortage of fun here as an engineer.
Awesome. Well, thank you so much for your time, Matthias. I'm so glad to have this personal demo from you on Flux. This is a real problem that I've actually tried to solve on my own, and to see it solved live in 20 something minutes is actually really compelling. I think you have a lot of confidence in your tool, but also you have a potentially unbounded problem of building hardware, right? Of building the iPhone. So
absolutely, there's an infinitely large market here, right? And it's just a capability that people haven't had at scale up until this point. And I think that's what's exciting here.
Awesome. All right. Thanks, Matthias.
Thank you. Have a good one.